A particle is projected from the ground with an initial velocity 20 meter per second at angle of 30 degree with horizontal. The magnitude of change in velocity in the time interval from 0 second to 0.5 second is blank meter per second square. In this question, we have to define change in velocity. Change in velocity. The final answer in the terms of magnitude, so we will define the magnitude of delta v vector. Okay, so here how to define delta v vector? So final velocity vector minus initial velocity vector. And we know that acceleration a vector is equal to change in velocity vector upon time interval. So here we have delta v vector is equal to a vector into delta t time. So here we have two different ways to define change in velocity vector by using vf vector minus vi vector, one way, and next second way is delta v vector is equal to a vector into delta t. So start with method 1. So we will take the first easy method. In this question, delta v vector is equal to acceleration into delta t time interval. The body is projected, a particle is projected under the effect of gravity from the ground. Consider this is the ground. Horizontal line. This is the velocity vector with velocity 20 meter per second at projected angle is 30 degree, and gravitational acceleration is vertically downward. As acceleration g vertically downward, it is denoted by minus j vector. So using this formula, here we have delta v vector is equal to replacing a vector by this small g into minus j cap into time interval 0.5 second minus 0 second would be 0.5 second only, and taking small g as average value 10 meter per second square is given in this question. 10 into 0.5 minus g cap is equal to 5 minus g cap meter per second. This is change in velocity vector. Here we have this answer in the terms of direction, 5 meter per second in negative y direction, and ultimate the magnitude is 5 meter per second. So here we have the option A is correct. And see here the next method. Method number 2. By using this formula, delta v vector is equal to vf vector minus v initial vector. Consider this is the horizontal line, velocity vector at here 20 meter per second, speed, velocity, angle is given 30 degree. Okay, 30 degree angle is given. So what is the initial at time t is equal to 0? Initial velocity vector would be taking the components of 20 meter per second along the x-axis. Here we have 20 cos 30 degree positive value, and along the y direction 20 sin 30 degree. So here we have initial velocity vector, x component would be 20 cos 30. Cos 30 means root 3 by 2, and 20 sin 30 as a y component of the velocity vector, 20 sin 30 1 by 2. So 2 into 10 is equal to 20, 10 root 3, and here 10. So it will be here 1.7, 10 into 1.7, root 3 means 1.7 its magnitude. So 10 into 1.7, the y component 10. This is 17, comma 10, v initial velocity vector. And after final time 0.5 second, Final velocity vector we have to define. So keep in mind, under the effect of gravity, here the acceleration is downward and velocity uh, perpendicular to the acceleration is 20 cos 30. This will be constant throughout the phenomenon because this acceleration does not change this magnitude. So along the x-axis we have the constant value of velocity 17 will be remaining, and here we will be the different in velocity in y direction. So in y direction, final velocity in y direction is equal to u plus 80. Initial velocity in y direction is 10 minus 10 as a gravitational acceleration because of retardation of the body in 0.5 second. So 10 minus 5 would be final 5 meter per second. This is along the y-axis. So final velocity vector we have 17,5. So here we have delta v vector is equal to vf vector minus v initial vector. Final velocity vector we have 17,5 minus 17, 10 initial. So x minus x component becomes 0, y minus y component 5 minus 10 minus 5 here. So from this solution we can also see change in velocity vector in negative y direction, and on the magnitude we have y meter per second. Thank you.